Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Jadi hari ini insya-Allah kumpulan kami akan membentangkan tentang chemistry chapter 3 iaitu periodic table. Jadi perkara pertama yang kita perlu tahu adalah dalam periodic table adalah period dan group. Period is 7 horizontal rows of elements which are numbered 1 to 7. Seperti yang kita boleh tengok ada 7 period dekat dalam periodic table. 7 period yang melintang. They are arranged in increasing proton number left to right. And same period equals to same principal quantum number. Jadi mana-mana elemen yang ada dalam period yang sama mempunyai principal quantum number yang sama. Kemudian kita beralih kepada group. Group adalah vertical columns of element in the periodic table. Dalam periodic table kita ada 18 groups dan elements yang placed in the same group have similar chemical properties dan same number of valence electron. Kemudian kita pergi kepada main groups in periodic table. Dalam group 1 adalah elemen yang bersifat alkali metals except H. Group 2 alkaline earth metals. Group 3 sampai group 12 transition metals. Group 16 chalcogens. Group 17 halogens. Dan akhir sekali group 18 adalah inert atau noble gases. Kemudian kita pergi kepada block. A block is a set of elements unified by the orbitals of their valence electrons or vacancies lie in. Each block is named after its characteristic orbital. S, P, D dan F block. So kita ada 4 block dalam periodic table. Tapi yang biasa ditanyakan kalau dalam exam ke dalam soalan hanyalah blok S, P dan D. Jadi antara elemen yang ada dalam S block adalah group 1 and 2. Yang berada di P block adalah group 13 hingga 18. Yang berada pada D block adalah group 3 hingga group 12. Kemudian kita pergi kepada contoh-contoh soalan daripada subtopik 3.1. Determining position of elements based on electronic configuration. Jadi contoh yang digunakan dalam soalan ni adalah phosphorus. Jadi langkah pertama kita perlu buat electronic configuration. Jadi cara untuk kita tentukan period adalah kita tengok apa dia punya highest principal quantum number N, dan pada phosphorus adalah 3. Dan untuk tentukan block kita akan tengok subshell occupied by electron of highest energy. Kalau dalam phosphorus ia adalah P. Kemudian untuk tentukan group kita akan lihat kepada valence electron. Jadi valence electron dia adalah 5. 3s2, 3p3. Jadi 3 tambah 2 jadi 5. Dan kita tahu tadi bahawa phosphorus ni adalah pada P block. So apa-apa yang elemen yang dalam P block, untuk dapatkan group dia, kita kena tambah electron valence dia dengan 10. Jadi 10 tambah 5 adalah 15. So phosphorus adalah pada period 3, P block dan group 15. Kemudian example kedua adalah untuk D block element. D block element valence electron are those in the outermost shell N and N-1 D orbital inner shell. Jadi dalam contohnya adalah number of valence electron dia adalah 9. 4s2 3d7. Jadi valence electronic configuration adalah 4s2 3d7. Dia adalah pada kumpulan 9 di block dan period 4. Sekian, terima kasih.
Next, periodic trends in the size of atomic radii. Ada 2 faktor yang menentukan atomic radii. Yang pertama, effective nuclear charge, iaitu apabila elemen berada dalam period yang sama. Dan yang kedua, shielding effect, iaitu apabila elements berada dalam kumpulan yang sama, same group. Yang pertama, across the period, from lithium, contohnya, from lithium, nickel and neon, from left to right, proton number increase. When proton number increase, effective nuclear charge increases too. Why? Because when effective nuclear charge increase, attraction of nucleus and electron valence will become stronger. Hence, size of atom becomes smaller. Secondly, moving down the group from fluorine, chlorine to bromine, number of shell increases. With that, shielding effect increases. Why? Because when shielding effect increases, attraction of nucleus and valence electrons become weaker. With that, size of atomic radii become bigger. Thirdly, across first row transition elements from scandium, chromium to nickel. All these elements are transition elements in period 4. Nuclear charge increased from scandium, chromium to nickel. Number of electrons added to 3D subshell increased from left to right. The increases of nuclear charge is cancelled by the increases of shielding effect of inner electron in 3D subshell. Hence, the atomic radii of scandium, chromium and nickel are roughly the same.
Okay. Isoelectronic species is a species that have the same number of electrons and hence the same electronic configuration. As we can see, Ar18, Cl-17 and Ca2 plus 20 all have the same number of electrons. So, how can we difference the size of the isoelectronic species? Look at the example. The question is, you are given Na+, Mg2+, O2- and N3- ions. Arrange the following ions in descending radius and explain. So, as we can see, the radius is N3- is bigger than O2-, is bigger than Na+, is bigger to Mg2+. So, what are the differences that make the radius of N3- is bigger than Mg2+? Even though they are all isoelectronic species, which is same electronic configuration, but they all have the different proton number. So, as we learned before, as proton number increase, effective nuclear charge will increase from N to Mg. The higher the effective nuclear charge, the stronger the attraction between outer electron to the nucleus. So, the stronger the attraction between valence outer electron and the nucleus, the smaller the size will become. So, if you look at the Mg, it will have proton number of 12, while the N have 7. So, this we can conclude that Mg is smaller than N. But this is only applied when it is in the same period. What if the element is in the same group? So we will use shielding effect reason. As down the group, the shielding effect will increase because the proton number will increase. So the number of electrons will increase. When the shielding effect increase, the attraction between nucleus and the valence electron become weaker. So when the shielding effects increase, the size will increase. It means down the group, it will be larger than upper groups. We also have the case of cation and anion. As in fact, cation is always smaller radius than anion. So that we can conclude any cation element will be smaller than an ion, while the anion will be bigger. So we can make the arrangement correctly based on the charge. Now to conclude the step-by-step to answer the isoelectronic species question. First, we have to write electronic configuration as always. Second, we have to determine whether it is in the same group or in the same period. So, if we know that, we will use the effective nuclear charge or shielding effect explanation. And 4, always remember that cation is smaller radius than anion. And lastly, now we can determine which one is bigger and which one is smaller.